Okay, sorry. All right, the solution now we need to express y in terms of x, but we need one more work. All right, the numerator always was complete factor. Okay,
Yeah.
but when you complete factor, we know that y is integer. Okay, but when you take this number 2 and 3, they are relatively prime. They can divide each other. They cannot. 12
Yeah.
integer, this number should be what? Divisible by 3, isn't it? Okay, we know that. Maybe if we use the modular arithmetic, that is easy way, but at this times, we just use the classic method, okay? Maybe I can see the modular over here. Oh. Okay, I don't know. Where is it? Okay, anyway, this one should be, we know that 501 minus x should be a multiple of 3, right?
Yeah.
We're going to check it out. But we already know that 501 divisible by 3, right?
Yep.
Because 167, isn't it?
Yeah.
This is what? When divided by 3, that is 501 divided by 3 equals 167. We know that. So maybe you can try x equals 0 first. Okay?
Okay.
When x equals 0, maybe you can solve here. When x equals 0, what is the y? 167, right?
Yeah.
167 times 2 is okay. So 334, right?
Yeah.
Okay. So the next one, multiple of 3 is what? Take up 3 again, right? Take up 3. So 5, when the next take up 3 is now, 0, the next number is 3, right? When x equals 3, 501 minus 3 is what? 498. Okay. This one can be divided by 3 again, right?
Yep.
166, isn't it?
Yeah.
166 times 2 is what? The value of y is what? 332, something like that. Keep going, right? Keep going. But until the maximum number x equals to 0, 351. If x equals 351, y equals 0, right?
Yeah.
Because 0 is available because they said non-negative integer, okay? 0 or positive. That's all the numbers. Pairs, right? When x equals 0, y equals 334. When x equals 3, something like that. So x changed from 0 to 501. Okay, how many of these numbers? The multiple, you know, the y.
168.
8.
Yeah.
Because to find one number multiple of 3, okay, 501 divided by 3, right? That is 167, isn't it? Because this is we counted from 1 to 501, right? But we still have a 0 here, right? So add 168 numbers.
Yeah.
Okay? So we have 168 pairs of this one. Okay, that's the answer, okay? Okay. That's the rule, right? Follow the rule, okay? First we have to express one variable, the other one is factored, and we need from here to earlier was we try to find the searching area, or a narrow searching area, okay?
Yeah.
All right. So we're gonna try number 1 over here. How many ways are there to write 2016, the sum of 2's and 3's? Okay, ignoring order. Okay. How many ways over here? This is fine, right? 2 and 3, but 0 is fine.
Yeah.
Okay, 0 is fine. So the next one is about 2 and 3, right? That's one of the methods. Okay, can you try this one? So the equation is, what is that? The number of x is 2. You can use this as 2x plus 3y equals 2016, okay?
Yeah.
But x and y should be greater than or equal 0, okay? But they are integer.
Okay.
Okay, can you try this one?
Yes.
How many pairs are there? Okay.
So if you rewrite the equation, so it's you isolate y, then the equation becomes
Okay, you equal y equals 2016
2016 minus 2x over 3.
That's it. So can you factor numerator?
Yeah. That's 1008. 2 times 1008 minus x.
3, right?
Yep.
Yeah, 2 and 3, they are relative prime. Okay, it can be divisible by each other.
Yeah.
The only thing is why to have an integer over here, this number should be divisible by 3, right?
Yeah.
But we know that 1008 already divisible by 3. 336, isn't it? 336.
Yeah.
Okay, so we can try this one first, when x equals 0 first, okay?
Okay.
So x equals 0 is okay. The next one, x equals 3 is okay too, right? We don't care about this. When you have one number of x, there are another number of y, okay?
Okay.
So this maximum number of x is how much? 1008, isn't it?
Yeah.
Like 1008, okay? So this number is, how many numbers are there?
337.
Yeah, 337, right? From here to here, 336. We need one more number there, okay? 337 is the answer, okay? All right. Now the next number. How many ways are there to write 2000? We did this one.
Is a sum of 3 and 4s.
Oh, a little different question. Okay.
Okay.
Almost, I thought it's the same question.
Yeah. So the equation is 3x plus 4y equals 2016.
Okay.
So then if you rewrite that, that's 2016 minus 3x over 4. And then you can factor it, so it's 3 times 6.
That's right.
672.
Yep.
Yeah. Minus x.
But first we can check it out, right? This number is divisible by 4.
Yeah.
Right, that's okay. So keep continue.
And then
so x can be 0, right?
yeah, x can be 0.
0 up to the next one is 4, 8, up to 672, isn't it?
Yeah.
Y is also the same number. So how many of these numbers?
There would be 169.
Yep.
Okay.
672 divided by 4 is 168. We still have a 0 here, okay? 169 is the answer, okay? Alright, just one more. I think this is 2012, but this is what? AMC 12 occasions. I forgot. Okay. So anyway, this is very similar, right? Okay.
Yeah.
Sometimes they give it similar. 12 plus 5 is 2020. How many? Wow, you're gonna be careful, okay?
Okay.
Positive integer right now, okay? It can be 0, okay?
Yeah.
All right. So, B equals?
B equals
2000.
2020 minus 2a over 5.
That's it. What's next?
And then you can factor it, so it's 2 times 1010 minus a.
That's it. Okay. All right. What are the first numbers?
Then the first number.
It cannot be 0, right?
Yeah.
But we know that 10,010 is divisible by 5 already. Okay, so A must be what? Multiple of 5.
Yeah.
Okay. Alright. What's the first number? Not 0.
5.
5, 10, up to?
Up to 1010.
No, if this is 1010 B to 0.
1005.
That's it. Okay. 1005. How many numbers are there?
201.
Yeah, 1005 divided by 5, right?
Yeah.
That's the formula to find the multiple, okay? 201 numbers, okay?
Yeah.
Excellent, very good. But don't forget this one, okay?
Yeah.
Yeah. Alright, the next one is the Beta's formula. You know the Beta's, okay? So sum and product. Alright, it's very interesting. So this guy looks like very brilliant, okay? So using coefficient, we're gonna find what very important was sum and product of the root. Okay, the first one, take a look. When you have the root, okay, when you generally, when you have a polynomial equation over here, this is a leading coefficient, this is second leading coefficient, this is a descending order, okay? Already when you arrange in descending orders, this is a constant, okay? Using this one, we're gonna find, okay, a sum of root first. Sum of root, any polynomial, any degree, always what is that? Second coefficient over first coefficient and minus, okay?
Yeah.
So R1 plus R2 plus always this one, I forgot, so minus AN minus 1 over AN. It's okay? Alright. The next one. Give me a minute. Okay, okay, it generate. Negative AN minus 1 over AN, okay? The next one. But still sum of root, but this time is what? 2 root, product of 2 root and sum of what? 2 product of 2 root.
Yeah.
Okay? So R1, R2, R1, R3, R1, R3, okay? This one, how can I say? Product of root, 2 root, okay? The next is R2, R3, R2, R4, keep continue, right?
Yeah.
If we have a root is what, this much. You can use 1, 2 product, okay? So this is product, a lot, alright?
Yep.
So finally it's about Rn times R1, okay? This one is about the next coefficient over first coefficient, but this is a minus, this is a plus. Change right there sign, okay? Alternately, it's okay?
Okay.
Now the third one, now 3 root product, okay? 3 root product, the next one is what is R1, R2, R3. R1, R2, R4, a lot. This is the next one, A, n minus 3 over A, n by this time minus. Okay? Do you follow me?
Yeah.
Okay, this is kind of what? The Venn diagram. Okay? Okay, especially we using what? 2 Venn diagram, okay? 2 Venn diagram. This is R1, this is R2. Okay?
Okay.
Over here, right? Times is R1 times R2, isn't it? Product. Right?
Yeah.
So when you have a quadratic first, okay? So ax squared plus bx plus c equals 0. Sum of root, because we have only 2 roots available, right? Because this is degree 2. So r1 plus r2 equals what? Negative b over a, right?
Yeah.
The next one is product. That's all. Okay? R2 equals what is that? C over a, isn't it?
Yeah.
Okay, alright. The next one. When you have the third root, there's a third root over there, fourth root. Okay, third root. Okay, I'm gonna do the express this, the other one. Just a minute. Degree 3, okay, I'm going to do degree 3. Okay. Ax cubed plus bx squared plus cx plus d. So we have a 3 root there, okay? So r1 plus r2 plus r3 equals how much? Negative b over a, okay?
Okay.
Now we have a 3 root, so product of 2 root, the next one, r1 r2 plus r1 r3. Okay, what is this? r1 r2 and r1 r3 and r2 r3, right?
Yep.
There's sum of, right, the product. This one equals what? The next is a positive c over a. Is okay?
Yeah.
The next one is all product 3. R1, R2. They are all. Okay? They are all. This is equals what is that? The next number is negative d over a. It's okay?
Yeah.
Alright, this is the first one. Okay, we're gonna try one more over here, okay, for in case, okay? AMC questions looks like sometimes give a right degree 4 polynomial, okay?
Yeah.
Ax fourth power, bx cube, cx square, dx, and plus e equals 0. We have 4 root there, okay?
Yep.
R1, R2, R3, R4, 4 root. Sum of root now how much? R1 plus R2 plus R3 plus R4 is how much? Negative b over a, same as before. Always negative b over a. We start from here negative number, okay? The next one is sum of 2 product. So R1, R2, R1, R3, R1, R4. Okay, from here. The next one, R2, R3, R2, R3, R2, R4. And the next one, R3, R4, right?
Yep.
This one is the next is C over A. It's okay?
Yeah.
Now the next one, 3 product, okay? R1, R2, R3 plus R1, R2, R4 plus R2, R3, R4. Okay?
Yep.
This is correct? R1, R2, R3, R1, R2, R4. The next one. R2, R3, R4. The next one, R3, R4, R1. Okay? All together is the next one is what? D over here, right? Negative D over A. Okay?
Yeah.
Minus, plus, minus. The next one is all 4. R1, R2, R3, R4 is now positive again. E over A. Okay?
Okay.
Alright, that's it. So especially a product of root. Okay, product of always a constant over a leading coefficient, right?
Yeah.
But degree of polynomial is what even number always about positive. But you know that this is always positive, right? This degree is the other number, we need a negative number, okay?
Yeah.
Negative C over A. Okay, that's the. Okay, now we have for over here, right? Yeah, for root is what? Especially over here, 0, you're gonna be careful here, okay? The next coefficient of x cubed is 0, isn't it?
Yeah.
Okay. Sum of root is what is that? Negative. Okay, over here, right? This is a degree 4 coefficient, degree 3 coefficient is 0, right?
Yeah.
Degree 2 coefficient is how much? 3. Okay. Degree 1 coefficient still 0, right? 0x. There's no x terms. So constant is negative 4, right? So that's why Degree 3 over degree 4 is what? 0 over 1 is 0, okay?
Yeah.
This is what is that? Sum of right 2 root. This is times, okay? 2 root is what? A2 over A4. 3 product. Last one, okay?
Okay.
This one x terms, the x terms over leading coefficient is still 0, okay?
Yep.
What is the last terms? Negative? Negative of 4, right?
Yeah.
Negative 4 over 1 is what? Positive of 4, right?
Yeah.
Oh, this is negative, I'm sorry. This is already negative, okay?
Yep.
So this is what? Even numbers, just one negative of 4 over 1 is what? Negative 4, that's fine, okay?
Yep.
Okay, using that Biertas formula, we try this one, number 1. Okay. We have 2 root over here. This is a quadratic. Find out sum of these two squares of root. R square plus beta square. Can you try this one? Okay, I'll give you some minute, okay? You can try. First, you have to set up the rule, right? We know that.
Yeah.
Sum of root is how much? Sum of root is how much? Negative b over a, right? Negative 5, isn't it?
Yeah.
And the product of root is how much? Negative 3 over 1, right?
Yeah.
Yeah, that's it. From here, you can find, okay? We're going to find what? Alpha square plus beta square, okay?
Mm-hmm.
All right, try this one. Can you express this one using alpha plus beta or alpha beta? Maybe you can try over here. Alpha beta square. How much this one? This was alpha square plus beta square plus 2 alpha beta, isn't it?
Yep.
So from here, we're going to find what these numbers.
Mm-hmm.
You get over here, right?
Yep.
But alpha plus beta is how much? Alpha plus beta is inside of a negative 5. So that negative 5 is equal to 25, isn't it?
Yeah.
25 is we need what? Alpha square plus beta square, right?
Yeah.
And plus 2 alpha beta is given over here. That is a negative 3 over here, right?
Okay.
So 2 times negative 3 is a negative 6. So alpha square plus beta square is how much? Plus 6 both sides will be 31 is the answer. Okay?
Okay.
Alright. Now we did 1 already. Okay, try this one now. You can do that, I think. Okay?
Yeah.
Okay, try this one. First set up the y.
So
The given. Okay?
Mm-hmm.
Alright. R1 plus R2 is equal how much?
Sum of the roots is negative
Negative 7.
Yeah.
Negative 7 over 1. That's the 7, right?
Yeah.
Product. R1 times R2 equals?
Negative 10.
Negative 10. Okay. Using these two, find out this value, okay?
Yep.
Okay, try this one. So you have to express, okay, 1 over R1 plus 1 over R2 with what?
So
Sum and product. Okay.
yeah. Can you cross multiply the?
Oh no, that is not cross multiply. That is not equation. When you have equation over here, you can cross multiply. Okay.
Mm-hmm.
This is not equation. This is just expression. What is the common denominator? R1, R2 is okay. 1 over R1 plus 1 over R2. Common denominator R1 and R2, isn't it?
Yep.
First, we multiply R2, right? Both sides, R2, right?
Yeah.
Second one is times R1 times R1, right? Plus R1, isn't it? Can you see that numerator now? What is that? Sum of the root. Denominator is what? Product of the root. right?
Yep.
So that is what, 7 over negative 10, right?
Yeah.
So just a negative 7 over 10 is the answer, okay?
Okay.
All right. Now let's try number 3. But this is a long time, so go write AMC questions. Okay?
Yeah.
Maybe number 1 or 2. Very simple questions. If you know this one. Alpha, beta are the root of the equation. That is quadratic. What is the value of this one? Wow, can you try this one? The idea is what is then? Same as number 2. We need to express, right? Sum of the root and product of the root. Yep. From here, we can see that alpha plus beta is how much?
8.
8, right? Alpha times beta is how much?
11.
11, isn't it?
Yep.
So we gotta use this one. That means what we're gonna express this one in terms of what? Sum and product. Okay? Right. So we need what is that? Factor, isn't it?
Yeah.
Okay, that's the idea, right? You know how to factor alpha cube plus beta cube? X cube plus y cube, right? That is cubing numbers. This one can be factored this way: x plus y, x squared plus minus xy plus y squared. The next way, x cube minus y cube can be factored this way: x minus y and x squared. But this is inside the plus, okay?
Yeah.
Okay, that is the factor. You need to memorize this one, okay? Okay. Now try this one. The first two we did already.
Yep.
Okay. This is alpha plus beta. The next one is what? Alpha square, right?
Yep.
Minus alpha beta.
Alpha beta
plus beta square, right?
Yeah.
Okay, that's it. The next one we're gonna find what? This we already know that. This product we already have over here. But you still have a right alpha square plus beta square, right?
Yeah.
So we're gonna find alpha square plus beta square. Alpha square beta square is what? Alpha plus beta square and minus what? 4 times 2 times
minus
alpha
2,
beta, isn't it? Right? It's okay? Alright, that's all. Okay, alpha plus beta, we already know that. This one is how much?
8.
8. Alpha square plus beta square is how much? Alpha plus beta is 8 square.
22.
Yeah, 8 square.
Yeah.
This is 8, right? 8 square is 64. Minus 22 is what? 42, isn't it?
Yeah.
Okay, so this number is 42. Right?
Yeah.
And what is this number? This number is how much? 11. No, 8. Right? Alpha square plus beta square, we already got this one. Alpha square beta square is 42. Yeah. And minus what? Alpha beta is 11, right?
Yeah.
This is how much? 8 times 31, isn't it? 8 times 31 is 248.
Yeah.
So this number is 248. So 248 plus 42 plus 50. Right? This is 50 and another 248, 298. That's the answer, okay? This is A because it's a number 1 or 2, I don't remember. It may be 1, I think. It's okay?
Yeah.
You can do that, okay? But this is algebra 2, right? The factoring of cubic numbers. You must memorize, okay? Alright, try number 4 now. This is also an AMC questions. Oh, that's no. I forgot to write multiple choice. Okay, anyway, that's fine. So R1, R2, R3 are the root of this cubic polynomial, okay? Alright, so what is the value? R1 square plus R2 square plus R3 square. What is that? First, can you find sum of root? I'm gonna write. Sum of root is what? R1 plus R2 plus R3 is how much?
2.
2, right? Very good. The next one. R1, R2, R2, R3, R3, R1, right? Sum of what? 2 product. That is equals to how much?
Negative?
5. No, 5. Okay?
Okay.
5. This is negative. The first one is negative 2 over 1. Okay? The next one is about positive 5 over 1. Okay?
Yep.
That's the 5. The next one, all product R1 times R2 times R3 is how much? Negative 7, but that is the other number, positive 7. Okay?
Yep.
So using this one, can you find the value of this one? Try this one, okay? Do you remember this one? R1 plus R2 plus R3
and then
square is what is that? R1 square plus R2 square plus R3 square and plus 2 times R1 R2, 2 times R2 R3, 2 times R3 R1. Okay, that's the factory. Okay, when you have right trinomial inside, you have to memorize this one. Okay.
Yeah.
So how can you express this one? You express this one, same thing.
Then that's
from 2. Here we subtract over here, right? So this is equals to actually what is the R1 plus R2 plus R3 square and take off this much 2 times R1 R2 R2 R3 R3 R1, right?
Yeah.
It's okay. So R1 plus R2 plus R3 sum of root is 2. That is 2 cube is I'm sorry, 2 square is 4 here, right? Now 2 times sum of right 2 root. Okay, 2 product. How much? This is 5 over here, isn't it? 2 times 5 is what? Negative 10. It's gonna be what? Negative 6 is the answer. Okay.
Yep.
All right. Yeah, this is also MB questions. I have to write down, right, the source. Okay. Now try this one, number 5. What is the sum of our root? Okay, can you try this one? To find the sum of root, we know that sum of root, what is that? Negative an minus over an, right?
Yep.
Okay, this is the leading coefficient. This is the next leading coefficient. Okay. To find this one, we need to find the descending order of the equation, right? Okay. We don't have to find all the root individual, just what sum of the root. Okay.
Yeah.
All right. Try this one. But this time to use the Beta's formula, okay?
Yeah.
You can expand this one, okay? What is it? 2x squared.
Yeah, 2x squared plus 3x minus 8x.
8 minus 5x, right? And 3 times negative 4 is negative 12. That's the first term. Second term is what is that? It's 2x squared.
2x squared
3x
plus 3x minus 12x. So that's negative 9x.
9x.
Then minus 18.
Okay, very good. Now simplify.
Then that's 4x squared minus 14x.
Okay.
Minus 30.
0. That's fine. What is the sum of root? Negative? Negative 14 over 4, isn't it?
Yep. So then that
7 over 2. Right? That's it, 7 over 2. Or in this case, maybe you can see the common factor over here, right?
Yeah.
2x plus. So you can move out. 2x plus 3 to move out. Inside is what? X minus 4, another x minus 6 equals 0, right? But this is a 2x plus 3. The second one is what? 2x minus 10. So from here we can find what? The two root. One is root 1, negative 3 over 2. The other one is 5, isn't it?
Yep.
So 5 plus or minus 3 over 2 is what? 7 over 2, right? Same number. Okay? Yeah, this is right. We can factor, okay?
Yep.
Alright. Now try number 6. Both root of quadratic equations are prime numbers. Root is prime. Okay? Both root is prime. What is the possible value of k? Can you try this one? Okay. Take time and try this one by yourself, okay? The root prime numbers. So we're gonna find some things about the root, alright? What is the sum and product, isn't it? So we have like two root. Maybe you can use like two root is what? Prime number 1, P1 and P2. Okay?
Yeah.
Okay, using this one, the number of possible value of k, okay? Find out.
So the sum is 63.
Yep, this one plus 63 and product.
And the
This is the
product
value
is
of k. We're gonna find this
k.
value of k, right? So how many value of k there? But P1 plus P2 is 63. We know that P1, P2 should be what? Prime numbers. Okay, how can you prime number? How can you find prime number? Maybe, but first of all, prime number is 2, isn't it?
Yeah.
You can try. You can try. 2 and 61, both will be prime. Yes, it's a prime.
Okay.
2 is prime. 61 is prime.
Yep.
Find out the other prime numbers. Okay, can you find out?
Okay. 3 doesn't work.
3 doesn't work.
5 doesn't work either. I think it's just 2.
Just 2, 61, that's enough.
Yeah.
Because what is that? Only 2 is what? Even prime number.
Yeah.
Or other one is the odd prime number, okay? They are odd prime number. So we know that sum of two prime number is even, this is the odd number, right? That's why one of the numbers should be what? Even, isn't it?
Yeah.
If they are the odd of a prime number, right? The 3 plus 5 should be what? Even number, okay? Okay? This is already even number. But this is what odd number means. One of the prime should be a 2. Okay?
Okay.
So 2, that's the only one. Alright? Alright. The number of possible value of k, okay?
Yeah.
How many?
Which
one is the answer?
Wait.
Possible value of k. Only one number of k, isn't it?
Yeah.
2 times 61 is how much? 122. This is the possible value of k. Only one number.
Okay.
Okay? So choice B is the answer, okay?
Okay.
Alright, try number 7 now. Okay, D and E denote the solution. Oh, that's the solution, right? The root. What is the value of D minus 1 and times E minus 1? Okay, this is easy one, I think, okay? You can try this one, okay? Okay, Nick, try. Always we have to find the relation, right? Sum and product of root.
Yep.
Okay, what is that?
Sum is negative 3 over 2.
That's right, negative 3 over 2.
And
Product.
the product is negative 5 over 2.
Excellent. That's it. Using this one, find out this number. Okay.
And then
Expand,
you can,
right? You need to expand.
yeah, into DE
Yeah, DE
minus E minus D, then plus 1.
This one is what is it? Plus, okay?
Oh,
So you can see, right, product and sum, right?
yeah.
DE is how much?
It's negative 5 over 2.
Sum is how much?
Negative 3 over 2.
And plus 1, okay? Now simplify.
So then that's
2 over 2.
just 2 or 0.
0 is the answer, okay? 0 is the answer. This is 5 over 2, negative 5 over 2, 0 is the answer, okay?
Yep.
Alright, the next one is for a certain complex number C, okay? C is a complex number, okay? This is not real number, complex number. And the polynomial has ejected of 4 distinct roots. What is the value of C? Okay, this is 2019 AMC 12C. Do you have any idea where complex root? Beta's formula, real root, complex root, it doesn't matter. Always Beta's formula, always working. Okay, right. But there are some of root is what is there, always real number, right?
Okay.
You can see product always real number, right? But root can be imaginary, okay? Because imaginary conjugate, isn't it? A plus, maybe you can use 1 is 3 plus 3i, the other one is what? 3 minus 3i, right? That is a conjugate, isn't it? When you add these two root, always what real, right? This is cancelled out.
Yeah.
Okay, or product. I'm going to use a different number. 3 plus 2i, 3 minus 2i. When you multiply this one, what is that? 3 squared is 9. 2i squared is what? Negative 4, right?
Yeah.
That is 13, isn't it? 9 minus negative 4, right? 13. This is a real number, right? But the root can be imaginary, okay? Alright. So C is a complex number, it can be imaginary. Okay, ejector have 4 distinct roots. What is the value of C? Okay, how can you solve this one? What is the root of this? Is a 4 distinct root. First of all, this is here, we don't know, but this one is the 2 root, this is the other 2 root already, okay? What is the root of here? Can you find the root of this one, these terms? Imaginary, right?
Yeah.
Okay, you know that the imaginary, you can use a complete square or quadratic formula, it doesn't matter, okay? I'm going to use a quadratic formula, okay? So you know that ax squared plus b, x plus c equals 0. Quadratic formula, x equals 1, negative b plus minus square root b squared minus 4 times ac over 2a. You know this already, right? Okay, so negative b is what? 2 plus minus, okay?
Yeah.
And let's say b squared is 4, right? Minus 4 times ac, right? That is 8, isn't it? Okay, 4 times 1, 2 is 1, negative 8 over 2, right? What is this one? 2 plus minus 1. Negative 4 is what? This is what? Square root of negative 4 is what? Is the 2i, isn't it?
Yeah.
Over 2 equals what is the 1 plus minus i, right? We have a 2 root. One is 1 plus I, the other root is a 1 minus y. We have right there a 2 root. What about this one? This one is also 2 root. You check it out. B squared, right? Negative b squared is positive 4 plus minus square root. B squared is 16 minus 4 times AC is about 32 over 2, isn't it?
Yeah.
That's the root. Now simplify this one. X equals 4 plus minus. This is how much? Negative 16, right?
Yeah.
That's a negative 4i. Okay. Alright, over 2 equals how much? 2 plus minus 2i, isn't it? Alright, that's okay. But you can see another over here. 2 plus 2i. The other one is 2 minus 2i. We already got 4 distinct root already. What about this one? How do you think? This one has what? Common root over there, right?
Yeah.
1 plus I or 1 minus I or 2 plus 2I or 2 minus I. That's why there are only 4 distinct roots, isn't it? They already got 4 distinct roots already. So the root of this one should be what? Belongs over here, one of this one. Okay?
Yeah.
But over here. But when you take over here. But sum of root we don't know. Which two we don't know, right? Which two we don't know. Anyway, they are a conjugate. Okay? They are a conjugate we don't know. But when you take over here, product of the root, this is a little bit hard, okay? Product of the root should be what? 4, isn't it? Okay, which two makes why product is 4? Can you find out? Which two makes a product of root? Because this is all real, you're gonna be very careful, right? When you have a real coefficient, real, right? Real root, isn't it? The real numbers. Always what? The root is a conjugate. Okay?
Okay.
But this is what? Complex already. This is not real. This is a conjugate. It doesn't have to be conjugate. You understood?
Yeah.
Okay, okay, for example, this is very important. Okay, I'm gonna explain over. When you have this one, x squared plus x minus 1 equals 0. Okay? This is right, coefficient is 1, coefficient is 1, coefficient is 1, right? They are all real real numbers. When you find the way the root, okay? The root is what? Negative 1, right? Over here, 1 over here, right? Negative 1 plus minus square root of 1 minus, okay? 4 times AC is negative 4, isn't it?
Yeah.
Okay? 4 times AC, this minus is positive 4 over 2, right? Because this is real, always what? The root is what? Conjugate. Negative 1 plus minus red 5 over 2, right? Conjugate. It's okay?
Yeah.
But in this case, this is what? For example, ix minus 1 equals 0. Okay? But in this case, the root are not conjugate. You gotta be careful because this is what? Imaginary. Okay?
Yeah.
So we gotta check it out. X equals how much? Negative I plus minus I squared is what? Negative 1, right? Okay? Minus 4 times AC is about plus 4, isn't it? Over 2. So negative I plus minus what? Red 3 over 2. Is this conjugate? This is not conjugate. Okay, conjugate is what? A plus minus BI. This is conjugate. I plus minus red 3. This is not conjugate, okay?
Yeah.
This one is move to the left. Do you understand? For example, 2 plus minus 3i, that is a conjugate. One is what? 2 plus 3i. The other row is what? 2 minus 3i, okay?
Yep.
But in this case, negative I plus 3, negative I minus 3, this is conjugate? That is not
no.
conjugate. You can use this one. 3 minus I, this one is what? Negative 3 minus I. Totally different.
Yeah.
Okay? They are not conjugate. So you gotta be very careful over here. Because they said this number is a complex number. Okay?
Yep.
It can be right both two, right? Conjugate, okay? But the only things we need what using this one, their product should be 4 over here. Which two numbers product is 4? Can you find out? Maybe you can try. This is not 4, right? We already did this one, okay? 1 plus 1 plus. Maybe you can multiply. This one is about 2, isn't it? This is 8. Totally different, okay?
Okay.
So we're gonna try this one. 1 plus I times 2 plus 2i. The product is 4. Can you check it out? Okay. Nick.
Yeah.
Try to find this right answer, okay? I'll be right back, okay?
Okay.
Just give me 1 or 2 minutes, okay?
Plus I. 2 plus 2I. Is it 1 plus I times 2 minus 2I? Or wait. Yeah, it's 4.
Hi. Okay. All right. So our product is 4. Okay. Now we try. Okay. So these two, right?
Yeah.
But when these two is not working, we know that the product is 2. Right? The other one is product A. So we can check this one and this two. But this is plus is what? It doesn't have a right 8.
Yeah.
Okay. So when you try to, okay, 1 times 2 is 2, 1 times 2 is 2i, 2 times I is plus 2i, right? That's not plus or minus. So we take one of the number is minus, okay?
Yep.
Okay, when you take one minus, so the I terms is imaginary terms going to 0, right? Okay, we try this one. 2 minus, we know that 2 is out. Maybe 2 is out. 1 minus I, isn't it?
Yeah.
This is a conjugate now, right? So what is that? This is 1 square minus I square is what? 2, isn't it?
Yep.
1 square minus I square, right? That is 2, right? So that is 4, that's okay. Right?
Yep.
Or you can try this one and this one too, which is working. 1 minus I times 2 minus 2i is 2 is what? 1 plus I. Okay?
Yeah.
This is how much? 2 is what? 1 square minus I square, still 2, right? So absolute value is how much? So C should be equal to how much? sum of the root, okay? We have to add this one, right?
Yeah.
So 1 plus I plus 2 plus 2I. How much is this one? 3 plus I, right? If we use this one and this one, right? How much? 3 plus I. Okay, this one plus this one is what? 3 minus I, right? We have two choices. C can be here and here. Okay. But that's when you find the absolute value of C. Absolute value of C is what is that? This one, right?
Yeah.
So how much this one? We know that the formula is what is that? 3 square plus 1 square, isn't it?
Yep.
3 square plus negative 1 square, which is what? Square root 10 over here, okay? So square root 10 is that, okay?
Okay.
This is very important, okay? This is kind of what 12 questions, AMC 12. Sometimes, okay, AME, okay, questions coming from this one too, using Y complex number, okay?
Okay.
You gotta be careful. Right, this was 2019 AMC 10A after it also was 2012. Hey, something like that, we're gonna find out. Okay, PQR be distinct root. So the root is different, okay? So x cubed minus 22, that's degree 3, that's fine. So exist why ABC, the real numbers. They said ABC is the real numbers. So it should satisfy this one. 1 over s cubed plus 20. Maybe this is the same thing, right? S cubed minus 22, s squared 80s minus 67, right? The down over here. This is one of the examples to a partial fraction over here, right? When you have this one, it can be separated using what their solutions, okay? So P, Q are the solutions, okay? Maybe you can say, okay, this equation is what? X minus P, X minus Q, X minus R, right? They can be factored this way. It's okay?
Yeah.
Right? Also, this is the same thing, right? This is the same thing, same formula. This is actually what is the S minus P, S minus Q, S minus R.
Yeah.
Okay, this is factored already. This is a partial fraction. A over S minus P plus B over S minus Q plus C over S plus R. Okay, S minus R. S minus R. But we decide to get the value of A, the value of B, the value of C, right?
Yep.
Okay, that's the rule. But in this case, what is the value of what? 1 over A plus 1 over B plus 1 over C. Okay? How can you start this one? How can you start this one? We're going to decide the value of A, B, C, isn't it? What are we going to do? We're going to write this one is what? Expressed using ABC, expressed what? This common denominator.
Yeah.
Right? The idea is what? Okay, not this common denominator is what? Still same as before, right? I'm going to write down from here. S minus, okay, a little down over here. S minus P, S minus Q, S minus R. Then the first one is 8 times what is that? This one times this one, right? We still have, they already have right? S minus P there, right? So 8 times S minus Q, S minus R, isn't it?
Yeah.
What about B? S minus Q there, S minus Q is out to be just what? Multiply S minus P and S minus R. It's okay. Now C, it already got S minus R over there, okay? This is there, over here. Just multiply S minus P, S minus Q, right?
Yep.
S minus P and S minus Q. That's it. Now compare. This is same common denominator, still numerator is 1. It's okay?
Yeah.
Alright. Now forget about this one, because this is what the origin equals. The numerator should be equals to 1, isn't it?
Yeah.
Alright. Now let's find the value of A. To find the value of A, okay, what are you going to do? to find the value of A. This make 0 over here, right? S minus P, S equal P. It is okay?
Okay.
Okay. To make a 0 term over here, the first one. This is very hard. The first one is S equals to P, right? What happened? Second term is 0, we know that. The first term is 1 equals A times, what is that? P minus S is Q, right?
Yeah.
S is, I'm sorry, P, right? So P minus Q, P minus R. Second term is what? This is 0. S equal P equals 0. All the way 0. That's the first one. Okay? From here, what is the value of A? What is the value of A? 1 over P minus Q, P minus R, isn't it?
Yeah.
Okay, that's it. The next one, second term is what? 0. Now S is Q now. Take a look. S is Q. Okay?
Okay.
S is Q is the first term is 0 over here, isn't it?
Yeah.
Okay? Okay, now we gotta find the B, right? So S minus Q is first term is 0. This is 0. The next one is what? 1 equals how much? S minus Q, okay, there's no Q over here. This one is alive, right? So B is out. So S is Q, Q minus P, isn't it?
Yep.
And Q minus R. Okay, that is equals to B. So from here, B equals how much? 1 over Q minus P and Q minus R. It's okay?
Yeah.
Minus R. Third one. Now S equals now R over here. R still this is 0, right? This is 0. This one is not 0. So C1 equals what? C over R minus P R minus Q. From here you can express C equals what is that? 1 over R minus P and R minus Q. That's it. Okay. Now we just got what? ABC over here, isn't it?
Yeah.
It's okay. Alright. But that's a reciprocal 1 over A. That's fine. 1 over A doesn't matter, okay?
Yeah.
1 over A is a reciprocal of this one. 1 over A is a reciprocal of this one, okay? So this one, okay, doesn't matter. So over here, 1 over A equals this one, right? We don't need to work. 1 over B equals this one. 1 over C equals this one, okay?
Yep.
Because the thing you find the A 1 over whatever, okay? We don't need this one, A, B, C. That's fine. Anyway, reciprocal, right? 1 over A is how much? P minus Q times PR, right? So what is that? P minus Q, P minus R. That is 1 over A. And the 1 over B is what is that? Q minus P, Q minus R, right? This is a lot of work. 1 over C is what? R minus P, R minus Q. Okay? Now we know that sum of root is over here. P plus Q plus R. I'm going to write down. Sum of root how much? P plus Q plus R is how much? From here. 22,
yeah.
right? The next one.
80.
PQ times QR times RP is how much? Sum of right two product. 80,
Yeah.
right? All product PQR is how much?
67.
67, right? Negative 67. That's all. Okay? Now we can find this value, right? Okay, now we no space. I'm gonna use this space, okay?
Okay.
This space. P times P is what? P square, right? The next one, P times R is negative PR. Negative Q times P, negative QP, and plus QR. Okay, that's the first one. Second one is Q times Q is what? Q square, and the Q times R is what? Negative. Okay. Negative QR. The next one, negative P times Q is negative PR plus PR, right?
Yep.
The next one, R times R is R square. R times minus Q is RQ. Negative P times R is negative PR. Negative P times negative Q is positive PQ, right?
Yep.
Okay, that's it. So over here, P square, Q square, R square, isn't it?
Yeah.
That's okay?
Mm-hmm.
Wow, this is a lot of work. Okay.
So that's
How much anyway?
J2.
Wow, this is correct? I don't know. Q square, R square, okay.
Yep.
And the PR, okay, Q, PR, let me see, PR, oh, what is PR, or not PR, PR. Oh. This is PR, PR, let me see, this is correct? PR, second one over here, right? Q times Q square, QR, PR, PQ, right?
Mm-hmm.
So this is minus PQ. Minus PQ and PR, that's fine, okay?
Yep.
All right. So negative PR is out. Positive PR.
Yep.
And what about QR? QR is out. What about QP? QP is out.
Yeah.
Now what you got? Negative QR, negative PQ, negative PR. That's it. Right?
Yeah.
Okay. Okay, now we're gonna find this was all plus. Okay, that's fine, right? That's fine.
Yep.
Okay, so we're gonna find the square of this one and minus this one. Right? This is already how much? 80, isn't it?
Mm-hmm.
Right, this is already 80. Now we're gonna find this one. This one you can find over here, right? This is what it is. P plus Q plus R squared, and the minus is what? 2 times PQ QR RP, isn't it?
Mm-hmm.
Do you remember? Okay.
Yeah.
That's the same thing, right? When you make a square and another minus 2 squared, you got this one, right? We did already, okay? Yeah. All right. So P plus Q plus R is how much? That is 22. Wow, this is correct? So complicated, okay?
Mm-hmm.
Anyway, we try.
Okay.
Okay, this one is 22 squared is what? 484. Minus 2 times PQ, this is 80.
160.
484, 160 is how much? 324,
yeah.
Right? This is 324, wow. So 324 minus 80 is how much? 244, we got 244, that's no answer.
Okay.
Uh, 324. PQR minus this into minus PQ, that's correct. 324. just got this one. Oh, there's no answer. What happened? 324 minus 244, right? 300 minus 244. Oh, we don't have answer there. Oh, no, over here. Oh, I'm sorry. This is number, not number 10, right? This over here, right?
Yeah.
Yeah, that is the answer. That's correct, okay? Yeah, this is actually correct. Okay, 244 here, okay? Yeah, that's the answer. So after class, okay, try this one by yourself.
Yeah.
Okay, you need to like get used to this type of questions. Okay?
Okay.
That is why hardest one in the Beta's formula, okay?
Yep.
On the AMC, okay?
Okay.
You can try this one by yourself, okay?
Yep.
First of all, you have to memorize this one, okay? A plus B plus C squared. This is why actually when you expand this one, you got this one, A squared plus B squared plus C squared, and the second term is AB plus BC plus CA, okay?
Yep.
That's why expansion. Special, what about this one? This one is how much? This one is how much? You have to can use this one, okay? Formula. A plus B plus C squared and minus 2 times AB plus BC plus CA, right? To find this one, from here you subtract this one again, okay? You have to memorize this formula too, okay?
Yep.
Alright. Okay, and also if you have any questions on your school work, you can ask me during the class, okay? But your school work, like GPA should be good, okay? GPA is very important, okay? So next time, okay? Because one of the guys is have some practice.
Yeah.
Okay. What is the activity, right? In the night time. So for the time being, you are only one student, so you can ask for your school work too. Okay. All right. Any questions?
No.
Okay. Now let's finish today. Okay.
Okay. Yeah.
All right. Okay. I'll see you next time.
Yeah.
Okay.
Okay.
I send out the video. Okay.
Yeah.
All right.
Bye.
Bye.